So 3 is basically 3 into 2 factorial, and this continues until I reach 1 factorial, and the value of 1 factorial is 1. This example is already explained in the previous lecture. So I'll use a recursive technique to solve this problem. Let's say I have a method named factorial, and n is the number. So the general formula of the factorial of a number is factorial of n is basically n into n minus 1 factorial, right? And we continue this until we reach factorial of 1, which is basically our base condition where I stop. Base condition is the condition where I stop. So at first, what I do is I check if n is equal to 1. If n is equal to 1, which means this is the last unit or the base condition where I stop, I simply return 1. I do not call factorial over here. Else, if n is greater than 1, then I calculate the factorial of that particular number, and then I return x. So let's see what is happening over here. I'm erasing this part, all right? I hope you understood what this portion means.
বুঝছি স্যার।
এখন যে স্টেপটা, please pay attention. This is my first method call. And say, let's say f is the function, a factorial quarterly club, no, it's quite a bit long word. So initially, let's say n is equal to 3. When n is equal to 3, I first check, go through this if condition, and n is not equal to 1, so I go to else. Then I compute x is equal to n, which is 3 multiplied by factorial of 2. And then I'll have to return x over here. Look, this particular line I'm computing the value of x. But to compute the value of x, I need two numbers. One number I have, which is 3, but I do not have the other number. To get the other number, I need to do a recursion again. That is why I am calling this function the same function. Over here, look, over here 3 is a concrete number. I'm not calling the function factorial. But over here, I'm calling the function factorial. So to compute x, I need to have two numbers. One I have, 3 I have. The second one I need to compute. Therefore, I'm calling factorial again. So this is where I call my second, I'm calling the function second time. So this is my second method call where n is equal to 2. n is not equal to 1, so I will not go inside this if condition. I'll go to else. Do the same thing. I'll compute x, which is equal to 2 into factorial of 2 minus 1, which is equal to 1. And then I'll have to return x. At this line, I call factorial, so this is my third method call where n is equal to 1. When n is equal to 1, I go to the if condition, and there are no more method calls in this condition. I'm not calling any method. I'm simply returning 1. So I'm simply returning 1. So return 1 means this particular value 1 will return in this place. I mean, this portion f1 will be replaced by the value 1. So return means return to the point where it was called. So the value 1 will be returned over here. Now I have two concrete values, 2 and 1. Therefore, the value of x is 2 multiplied by 1, which is equal to 2. X is 2. And now I'll return the value of x. I mean, this value 2 will be returned from this place to this place. So this portion will get replaced by the value I have returned. Now I have two concrete numbers, and I can compute x, which is equal to 6. And finally, I return the value 6 where I called the function the first time. So somewhere in my code, I have called the function factorial and have given with the number 3 in its argument. Now I have the result, which is 6. F stands for factorial, okay?
Sir, একটা ছোট question. For
Yes,
this
yes.
function, n equals to 0 দিলে তো it would end up in
n
an
equal to
infinite
0 delay. Therefore, for that, you can include another if condition, that if n is equal to 1 or, you can return 1. I'm not sure what is the value of 0 factorial. I
It's
think it's 1.
supposed to be 1.
Yeah. So you can add this condition as well. So if n is equal to 1 or n is equal to 0, then you can simply return 1. So this is called the base condition. Base condition means where I'll not go further. No more method calls, right? So in recursion, what basically happens is I break a problem size. So I have a problem. And in this example, which was equal to 3, the problem size was 3 for this example. In recursion, what we do is we break the problem size at every step until the problem size is 1. We compute, or we find the value of this smallest unit and then return it to the previous step. So the solution of this step is returned to the previous step, and then find the solution of this step and return the solution to the previous step. So once you go through the lecture of the recursion basics, I bet you understand. There are 2 lectures you need to go through. One is the recursion basics money posted in box, and the other lecture is the lecture of the previous week.
Previous week, you mean stacks?
Not stack, recursion. We did stack before the midterm. After the midterm, I took another lecture where I explained recursion. So if you're having difficulties, we can stop today. I can give you the lecture You go through the lecture, and then you can come tomorrow at 8 a.m. I have a class at 8 o'clock tomorrow.
Sir, I actually understand this, so you can continue if you
ও আচ্ছা
like.
আচ্ছা তাহলে তাহলে তো তাহলে কোনো সমস্যা নেই। আচ্ছা, so let's look at another example. Let's say length of a string. So you'll be given a string, and you'll have to find the length of a string using recursion. So length of a string is basically 1 plus length of the rest of the string. Again, this is the step you need to break further. So this is again 1 plus length of rest of the string. And this continues until you just have one character left, and the length of one character is 1. And you return. So is basically this character plus the length of this substring. Again, this is basically e plus the length of v, which is 1, plus length of the rest of the string. This is again the length of the first L, which is 1, plus length of the rest of the string. Again, 1 plus length of O. This is just one string. So I can simply write 1. The length of one string is 1. I can return it to the previous step. So when I return, so my base condition is, if this is my function and I have the string, and let's say I have another I might also have an integer. I'm not sure what the complete question. There are many ways to solve this. If I have mm, not sure, wait a second.
Sir, if we're using Python, we can simply go through the string, right?
Yeah, you can do that even
As in
using Java, no
think
problem. Like in Python and in Java, you can simply find the length of a string using one command, right?
No, no, no. I wasn't talking about that. Like you
Uh,
guys are trying to do this without that, right? Um,
without the built-in function. Built-in
without the
function.
built-in function. I'm saying, Jay, we can use slicing for this part, right?
Yeah, yeah.
For
You can. I mean, you have to use slicing for this one because you have to find the substring at every step. So you have
yeah,
to
yeah,
use slicing. If you're using
yeah.
Java, it's I mean Python, it's slicing, and if you're using Java, I think it's called substring. This is Python.
Yeah, so if we for the condition we can simply do J, as long as the substring isn't an empty string, the you know the
Yeah,
other
yeah,
condition will
exactly.
run.
That's true. So we can simply return a zero. Else, we can return one plus length of rest of the string, right? So this will be a return type function. In the previous lecture, I have explained which are return type and which are void. This has to be return type function because at every step there is a portion waiting for the next step. So this portion is waiting for the next step, and this portion is waiting for the next step. So whenever you find the concrete answer or a concrete value, you must return to the previous step because it's waiting for you. And when you return one to the previous step, this portion gets replaced by the answer you return. Then you do the addition, which is equal to 2, find the answer, and you return the value 2 in the previous step. Do the summation and return 3 in the previous step. Do the summation, return the answer in the previous step, and then do the summation, and finally return it to the command where you actually call the function. So the final result is 5. A lot of students find it difficult to understand when to use a void function and when to use a return type function. Please go to the previous lecture if you have difficulties understanding when to use what is void and what is return, when to use them. Okay. We can also find length of a linked list. Linked list, finding the length of a linked list is very much similar to finding the length of a string, except for the fact that strings have characters. So this is basically 1 plus the length of rest of the list, right? Again, 1 plus length of rest of the list. The stopping condition will be when you reach null. When you reach null, the length will be 0. And the starting condition, I mean, if this is the function, you'll be given the head. So you start from head and then do the same thing like the previous example. 1 plus rest of the list. And this will also be a return type method. So these are very basic examples where we can use recursion. We can use recursion basically in every problem. A bit more complicated are when we are sorting, because in sorting problems we have nested loops. All these problems I've shown you so far are single loop problem. So we replace one single loop with one method call. And when we'll have nested problems, multiple loop problems, we need to have two functions or two methods to deal with each of the loop. For example, in selection sort, we have two loops where we basically the first loop is basically for traversing, and the second loop we use is for finding the maximum, if you remember. Did you do selection sort in CSC 111? I'm not sure.
We
Or
did it in 110, I think.
any sorting algorithms in 111?
111 or 110 maybe.
110,
Yeah,
110.
110. We did it
Yeah.
for 110.
No, did you do any sorting algorithms in 111 or no sorting
No,
algorithm?
no,
No.
no.
Nothing. Okay, okay. Okay, then we'll leave the sorting parts for later. When we solve selection sort, I'll show you how to solve selection sort using recursion. But the basic idea is if you have multiple when you need to replace multiple loops, you need to have multiple methods. One method for each loop. So things might sound a bit difficult, but when you actually do recursion, it will get easier because let me show you an example. Let's say I have an algorithm named algorithm 1 to solve a problem P, let's say, and I have performed some lines operations, and then I have another for loop. And for example, I have three nested for loops, right? If we have to convert this problem into a recursive problem, we could simply write one method for this one, one method for this one, and another method for this one. In this program, all these operations are written all together. But if we write methods for each for loop, things will get less clumsier. Then we could simply do this. Inside the method 1, I'm calling method 2, and somewhere I'm calling method 3. And somewhere I have method 3. So I have separated each of the for loops. So this gets less clumsier. And for example, if you need to deal something with only on this portion of the code, I can simply look at this scope, right? I can only look at this function. I do not need to look at the whole picture. So when we are dealing with nested loops or programs with a lot of for loops, it's best when we separate them using function, using methods. Things get very less clumsy and we can deal with one method at a time. We do not need to look at the whole picture at one time. So recursion is is very handy when we try to perform the same thing over one problem set or one problem set or the same input. For example, I have an array. For example, I have a matrix and some of the squares are colored black. This is where I start from, right? This is my starting point. And my program is to count the number of black squares. So this is basically simple. I go through every column of every row and count the number of black squares. So these kind of problems are very handy when we use recursion.
Sir, I don't get what you mean by black squares. Like,
Black,
what did you mean by this part?
I mean color. These are white and these are black.
No,
For
no, no,
example,
not the color. Like, I didn't get the question. Like, am I supposed to spot them or what?
no, count the number of black squares.
Okay.
And for example, I can make things even more complicated where I can restrict your movements. I can say you can only move to left and down. You cannot move sidewise or you cannot move backwards. So you will come across a lot of problems where you can easily solve using recursion. One problem I solved back in those days was something like this. I was given a square. I'm in a huge matrix. So the problem set was something like this, I remember. So this was my problem set and I had to count the number of perfect summation signs. By a perfect summation sign, I mean if this is the middle, all the other sides will have equal number of black squares. I mean, look, this is a perfect square. I have one black square on the right, one at the top, one at the left, and one down. So in this particular example, there are two perfect squares, 1 and 2. So this was a problem I solved a lot of years ago where I had to use recursion. And this problem was very easily solved using a recursion. So you can take this as a challenge. You can try this at home.
I'm sorry, but how am I supposed to read this?
For example,
No, like I understand it as a human being, but how am I supposed to make my program read this?
so you mean how you write, your program will understand black and white? Simple.
Black
Make
and white or just this entire matrix box circuit?
black is okay. Look, this is a matrix. You haven't solved any problem with matrix yet, right?
I haven't. We haven't. We
Okay.
didn't learn
So
about matrix yet.
to give it a, this is very easy. In Python, just do a search, matrix in Python or in Java, any programming language you're using. So you have, this is like an array inside an array. An array looks like, in an array, it's simply a row matrix, right? A row. And in a matrix, you have multiple rows. These these indices are columns and rows. So you can access a particular box using a row number and a column number. Let's say black box is indicated by the number 0 and white boxes are 1. So you can first create a matrix and then you'll manually set these boxes to zeros and ones. If you're using an integer matrix, the initial values are already zeros. Okay. Okay. So if the larger number, okay, do this. This will be easier. White, black for 1, white for 0. So what you do is manually put 1 in these boxes and then write a program to count the number of perfect squares. I mean perfect summation signs. For this particular example, your answer will be 2 because there are 2 perfect summation signs.
Why two? Shouldn't there be like four?
No.
Because no, just listen to this. I mean, on the bottom there are like the bigger summation sign. You can just consider it to be a small, you know, one of the smaller plus signs. And then on the right hand side, on the top, if you disregard one of those
No, you
black
cannot
boxes.
disregard. No, you cannot disregard. This is your input. So this is not a perfect summation sign because this has an extra, black square added to it.
So I'm just going to read the four diagrams as four parts. I mean, sorry, the four spots as four different parts, and then judge them whether they total equal to a plus sign.
Yeah, there are basically 4 structures in this example. 1, 2, 3, and 4. And out of these 4 structures, only 2 of them match with your question, or match with the criteria mentioned. These 2 do not match with the criteria, so these are not. So these will not be included in your answer. So the definition of a perfect summation sign is you'll have equal number of hands on the 4 sides. If you consider this to be the middle, you have 1, 1, 1, 1. On this one, if you consider this to be the middle, you have 1, 2, 1, 2, 1, 2, and 1, 2. So these 2 are perfect summation signs, and these are not. Because if you consider this to be the middle, you have 2 on the right, 1 on the left, 1 on the top, and 1 at the bottom. And over here, this is not a summation sign at all. So you do not need to detect if it's a summation sign or not. You just find out whenever you come across a black box, see if you have hands on the left, right, top, and bottom. So if you look, first of all, for example, you come across this particular black box, and then you check if you have hands on all four sides. So you do not have a hand at the top, so you do not need to check further. So this is not the middle of a summation sign. And then go to the next one, for example, this one. So for this black box, you check if you have four hands. Yeah, you have four hands. And then for each hand, count the number of, I mean, consecutive black boxes. So you'll have one on the right, you'll have one on the left, one at the top, and one at the bottom. And when these counts match, you can consider this to be a perfect summation sign. A bit, a dip, an advanced problem, but fun.
But sir, considering what you said, then the the box on the right side that I was talking about, that would also give us a correct output. Like once we go to
No, no, no,
the
it will not. For example, at first you come across this one. So you do not have a hand at the top, and also at the left. So from this particular square, there is no summation sign at all. Then you move to this box. There is no hand at the top. So there is no summation sign from this box as well. Then you come across this one. Same goes for this one. There is no hand on the left and on at the bottom. So no summation sign from this particular box as well. And same goes for this. Nothing at the right, nothing at the bottom. And on the right, it's a dead end. It's a dead end. So whenever you look, the algorithm should be like this.
Sir, I was sort of thinking in a different way for this solution, which was that considering the size of my matrix, could I possibly find out the possible answers? For
No, no, no,
example,
no, no, no. What you're trying to do is no, no, no. Possible answers. You do not need to find the possible answers. Why
and
would
then
you
like
go for that?
match.
There could be a lot of possible answer from this one. You just find out how many answers are there in your input in your problem set. That's it. What if I give you a totally empty box? What if the user gives you a totally empty box and asks you to find the number of squares? Now, would you need to find out all the possible answers, and then at the end you find out there's no answer at all? That's not a very good technique, right?
Yeah. Okay.
You do not need to find what could be the answer, just find the answer. That's what could be the answer. It's a huge task to perform. Because for every box there could be multiple summation signs. For this one there could be one. For this one there could be two summation signs. I mean, one, two. I can have one hand summation sign. I can have two hands. No, one hand only. For this particular row, I can have, for every box I can have one summation sign. For this particular row, I can have one. From here I can have two summation signs, because I can have a one hand summation sign from this one. So no need to find out the number of possible answers. Just find out how many summation signs you can detect. So what you do is go over the lectures again, and then next time when we meet, we can discuss more. Or I was thinking of recording a video with advanced examples and posting it, because in lectures in the morning, I didn't have too many students as well. Are you guys there?
Yes, sir.
So when you do not have too many students, it's a bit difficult to teach. You know.
Yes,
So any
sir.
more questions you have?
Not really.
Okay, go over the lecture. So if you have any questions, please do ask me in Slack. I'll try to explain.
Okay, sir.
So if you do not have any more questions, I think we can end the lecture today.
Thank
Yeah.
you, sir.
Okay. Thank you very much.